Wonderful people. We are back, and in the last three videos, we've covered sections 6.1, 6.2, and 6.3, which are how to solve systems of equations. We had three methods: solving by graphing, solving by substitution, solving by elimination. And now in section 6.4, we're going to talk about how to decide which method you should use, just as a quick summary or review. And then we're going to learn how to solve some word problems that involve systems of equations. Okay, so let's go through how you decide which method to use. And this is all written in already in your notes, so all you have to do is follow along. Okay, so when would we use graphing? When would we use graphing? Well, if you're given direct instructions to graph, obviously it says to graph, you're going to use graphing. If they're both in slope-intercept form, especially if the slope is a fraction, okay? Here's an example: y equals 2/3 x plus 1, y equals 1/2 x plus 2. Well, why would we do that? Well, both the substitution and the elimination forms, they can be a little bit unwieldy or difficult if we have fractions involved. So it's often easier just to graph if we have a situation like this. So if we're in slope-intercept form, y equals mx plus b, and if we have slope as a fraction, graphing might be the ideal way to go ahead and solve. Sorry about that, mouse. Okay, well, what about substitution? Well, obviously, if it says to use substitution, you have to use it, and there will be some questions that I'll give you on your quizzes and tests where you'll have to do that. But if one variable is already solved for, so what if we had this set of equations: 2x plus y equals 5, y equals 3x minus 1. Well, here we have one variable that's solved for, y, and we can just plug that into this other equation. Okay? So we just plug the equation that's solved for y into the y in the equation above. So that's when it's good to use substitution. You could also do it if it seems really easy to solve for 1. So if it seems easy to solve for y or easy to solve for x, like it's just one step away, that might make sense, and then plug it in. Okay? Then finally, we've got elimination. When would we use elimination? Well, obviously, if it says to use elimination. If there are really big numbers get hard to graph. They also get hard to substitute for. So if there's big numbers, it can be good to use elimination. And then if both equations are in standard form, remember standard form? Ax plus by equals c. In Ax plus by equals c, if they're both like that, it tends to be pretty easy because they're lined up. So you've got 3x plus y equals 12, 5x minus y equals 8, right? And then lastly, if something easily cancels out. When we look at these, we can see we've got a positive y and a negative y. All we got to do is add them together, and the y's are gone. All right? Now, a lot of times you could use all three forms. So this is a good example of one where the easiest way would probably be to eliminate, but you could also solve for y here, right? Just subtract 3x from both sides and plug that in. Or you could graph those two. But elimination is the best option because it's so easy just to cancel them out. So graphing, all of them, if it says to do it, do it. But graphing's best if they're in slope-intercept form and you have fractions for the slope. Substitution's best when you're already solved for 1. Okay? And elimination is best if they're both in standard form and it's easy to cancel something out. All right? So that's all a way of introducing word problems. Because when we get word problems, I'm going to zoom out a little bit, make this a little bit easier. Right? When we get word problems and we have to solve word problems, you're going to have to choose which method you want to use. Choose which method you want to use. Okay? So this is section 6.4. Solving word problems with systems of equations. Okay? So there's 4 easy steps to this. The first is to define the variables. This is very important. When you get a word problem, you don't necessarily have variables like x and y. So you need to decide on the variables. Okay? Step 2 is going to be to write 2 equations. We're dealing with systems of equations. That means there's 2 different equations. Step 3 is going to be choose your method: graphing, substitution, elimination. Step 4 is going to be to solve. So let's look at example 1. All right? Let's look at example 1, and this is about me. So it says, Dr. Marty sells tickets for the school play and collects a total of $104. The total is $104. Admission prices are $6 for adults and $4 for children. Dr. Marty sells a total of 21 tickets. How many adults' tickets and how many children's tickets did he sell? Okay, well, what I see, right, is that I need to know. What do I need to know? I need to know the number, right, of adults' tickets and the number of children's tickets. Okay? So let's start by defining our variables. Now I'm going to use A and C because it's easy. You could use any variables. But I'm going to say that A equals the number of adult tickets. And I'm going to say that C equals the number of children's tickets. Makes sense, right? I'm looking to solve for the number of adult tickets and number of children's. I'm going to have A as the number of adults, C as the number of children's. It says write two equations. So let's look back up at our information. Okay, he sells tickets for the school play and collects a total of $104. If the prices are $6 for adults and $4 for children, right, how could we get a total? Well, 6 times the number of adult tickets plus 4 times the number of children's tickets is going to give us the total 104. So 6 times A will give us the total amount of money that comes from adult tickets plus 4 times C, which is the total amount of money that comes from children's tickets, is going to equal 104. Right? Now I'm going to leave out the money sign. We know we're dealing in dollars here. All right? I'm going to leave out the money sign. Then what's the second equation? Well, it says Dr. Marty sells a total of 21 tickets. That means the total number of adult and child tickets are 21. So that means A, the number of adult tickets, plus C, the number of children tickets, equals 21. Okay? Now it says choose a method. Choose a method. Now, graphing, not ideal here. All right? Not ideal here just because using these numbers, neither of these are in slope-intercept form, right? I also see some big numbers, 104 and 21. Remember with big numbers, if we go back here, I'll try to plug this in nice and easily. Yep, if there are big numbers, they recommend elimination. So let's use elimination here. Let's use elimination. Okay, so I'm just going to circle elimination. All right, so let's solve. Let's go over here and solve. 6A plus 4C equals 104. A plus C equals 21. All right? So what I want to do is I want to get this in a situation where we can cancel out, let's cancel out the C's. All right? So we've got 4 here, we've got 1 here. So I'm going to multiply this by 4. Okay? That whole equation by 4. So I'm just going to carry this over. 6A plus 4C equals 104. This is going to get multiplied by 4. 4 times A is 4A. 4 times C is 4C. Equals 4 times 21, which is 84. Now I can subtract. 6A minus 4A is 2A. 4C minus 4C is 0. That equals 104 minus 84, which is, conveniently, 20. Solve for A, divide by 2. A equals 10. Now we just got to plug this new equation. Well, this is a really easy one. A plus C equals 21. I can plug this in here. 10 plus C is 21. Subtract 10 from both sides. I get C equals 11. So our answer is 10, 11, or 10 adult tickets, 11 child tickets. Okay, so we defined our variables, A, the number of adult, C, the number of children's. We wrote two equations, right? We had total of $104. 6 times A plus 4 times C is 104. We had total number of tickets, 21. A plus C is 21. Chose elimination because we had big numbers and they weren't in slope-intercept form. Solved elimination, we got 10 and 11. Pretty straightforward. Okay, let's do our second example. It says, Miss Flote's family goes to a restaurant for dinner. Some people order the chicken dinner for $14.80. Some order the steak dinner for $17. Okay? If the total bill was $91 for 6 people, how many people ordered each type of dinner? Ooh. Okay, well, we got to define our variables. It says, how many people ordered each type of dinner? I see each type. So we need to know the number of chicken dinners and the number of steak dinners. So let's have C equal the number of chicken dinners and S equal the number of steak dinners. Let's write two equations. Okay? Well, the total bill is $91. Each chicken dinner is worth $14.80. Each steak dinner is worth $17. So that means that 14.80 times C, right? 14.80 times the number of chicken plus 17 times s equals the total, which is 91. Okay? Then there are a total of 6 people, so that means the number of chicken dinners plus the number of steak dinners equals 6. Now let's choose a method. Well, is this set up for graphing? Not really. It's not in slope-intercept form. Is it great for substitution? Well, we could use substitution, but we got some big numbers here, big numbers. So it's going to be easier again to use elimination. Okay, so let's go ahead and solve. We've got 14.8. I'm going to take the 0 off just because it's the same, right? C plus 17s equals 91. C plus s equals 6. All right, I'm going to get rid of this. I have a 17s and I have an s here, so I know if I multiply by 17, I can get rid of it, right? So 14.8c plus 17s equals 91. Multiply by 17. 17 times c is 17c plus 17s equals 6 times 17. 6 times 17 is 102. Subtract. Okay? So negative 14.8c minus 17c is negative 2.2c, right? Negative 2.2c. Our s's cancel, and that equals 91 minus 102, which is negative 11. I can divide by negative 2.2, and I don't need a calculator because this is straightforward. C equals 5. Number of chicken dinners is 5. Well, now this is pretty easy, right? C plus s equals 6. Plug 5 in here. 5 plus s equals 6. Subtract 5. And s equals 1. Okay, so we're at 5, 1, or 5 chicken, 1 steak. That is, ooh, you can't see that. I'm sorry. My bad. Okay, 5, 1, 5 chicken, 1 steak. All right, so solving word problems with systems of equations, define the variables, write 2 equations, choose a method, either graphing, substitution, elimination. Elimination often works really well with real-world problems. Go ahead and solve, find your solution.